Hello there, Mr. Sutton here, bringing you the Algebra 2 6-2 homework solutions on the natural base e. For these first few problems, we're just simplifying expressions with e in them. So we're just going to treat e pretty much like a variable using our exponent rules. So if we're multiplying these bases, we have to add the exponents. So this is e to the 3 plus 5 or e to the 8. To simplify this expression, we're going to have to subtract some exponents. So 11 over 22 is going to be 1 over 2. And then this is going to be 9 minus 10 for the exponent, so negative 1. And if we wanted to, we could move that into the denominator and call this 1 over 2e to the positive 1, or just 1 over 2e. On this problem, using our exponent rules, we have to apply the fourth power to the 5 and the e to the 7x. So 5 to the fourth is going to be 625. And for the exponents here, we're going to multiply the exponents. So this is going to be e to the 28x. For this problem, we have to square root the 9 and the e to the 6x. Square root of 9 is just 3, so nothing fancy there. But now when you square root something with an exponent, you're dividing the exponent by the index, in this case 2. So this is going to be e to the 3x. For this problem, we have not 1, not 2, but 3 expressions with e. We're just going to add the exponents since we're just multiplying the same base together. So x plus negative 6x is going to be negative 5x. And then this 8 can't really be combined, so we'll just keep it there in the exponent with the negative 5x. For this problem and the one after it, we need to figure out if the function is exponential growth or decay, and then graph it. For this one, we've got basically e squared is my base on this one. And I mean, e by itself is already 2.7, so if I square that, that just becomes bigger. Since my b value is greater than 1, that means this is exponential growth. Now we're going to go ahead and plug this in. Plug in negative 2 through 2 into this. So let's do that on Desmos. So we've got e to the exponent 2 times negative 2. That comes out to 0.02. Let's do negative 1 as well. That's going to be 0.14. And then e to the 2 times 0 is just e to the 0, or 1. Now we've got e to the 2 times 1, which is about 7.39. And then e to the 2 times 2 is about, well, 54.60 if we round that off. So I'm going to need some big y values to get to 55-ish right there. I'm going to make my y's go by tens. So graphing all these out, we've got negative 2, and this is almost 0. Negative 1 and a little bit more than 0, but still pretty close there. 0, 1 is not much on this scale. 1, 7-ish is somewhere around here, and 2, basically 55 is right about there. And then let's just connect the dots with a nice horizontal asymptote as we go to the left. All right, so for this one, let's see if this is growth or decay. Our b value on this one is actually e to the negative 0.5. So what is that numerically? Well, let's go to Desmos and just plug it in to see. We got e to the exponent negative 0.5, and that's about 0.6. So that definitely is between 0 and 1, which means this is decay. So let me plug in negative 2 through 2 just to get some values and put them on a graph. So going back to Desmos, let's do negative 0.5 times negative 2. That comes out to about 2.7. Now we actually also have a 4 out in front, so let's not forget that. There we go. So that's 10.87 then, that all comes out to. And if I plug in negative 1, let's go back to the exponent. So that's about 6.59. If I plug in 0, that's 4. Plugging in 1, we've got about 2.43. And then plugging in 2, that comes out to about 1.47. So graphing all of these here, we've got negative 2, and this is about 10 and some change, about 11 actually. Negative 1 and, let's see, 6.5 1.5-ish, somewhere around there. And then 0, 4 is right there. That's easy. 1, 2 and a little change is somewhere here. And this is 2, 1.5-ish. So that's about 3/4 of the way up there. And then let's just draw a line connecting those. And again, we have that horizontal asymptote as we go to the right. For this problem, we've got some continuous compounding going on. We're investing $60,000 at 1.15% for 25 years. So since we're compounding continuously, we go straight to the PERT formula here, PE to the RT. So we're plugging 25 in for the t value, and then our principal is 60,000. We've got e to the interest rate here of 0.0115 if we express that as a decimal, and then t is 25. Let's go ahead and plug all that into Desmos. And let me just move this so I can see. There we go. So 60,000 e exponent, and then we got 0.0115 times 25, about $79,985.43. 44 cents? Yeah, 44. We have to round up there. There we go. For this one, we're investing $1,700 in an account with an interest rate of 3.52%, continuous compounding. So we want to know what's happening after 14 years. We're going to use the PERT formula because we're compounding continuously. So we're doing f of 14 equaling our principal of 1,700 times e to the, let's see, 0.0352 times 14. Going to Desmos to plug all that in, we've got 1,700 e exponent 0.0352 times 14, and that's about $2,782.72. On this one, we have investment accounts for a house and education earning annual interest compounded continuously, so that's our tip-off. We're going to need PERT. The balance of the house after t years is modeled by this exponential function, 3224 times e to the 0.05t. And then the graph shows the balance of the education account over time. We want to know which one had a greater principal starting amount and which account was better after 12 years. So for the principal for the house, that's going to be this 3224 out in front. That's always your principal, is that initial value, that coefficient. And for the education, that's the y-intercept on the graph, which they said is 4,856. Well, it looks like education principal wins this one. Let's go ahead now and figure out the balance after 12 years. To do that for the house, we just have to plug 12 into the formula that they gave us here, 12 for t. But I will need to do this on Desmos. So 3224 e exponent 0.05 times 12 is $5,874.51. And then looking at the 12-year total on the graph, it's hard to tell, but this is between 7,000 and 8,000. Want to call it like maybe 7,700 or 7,800, which in any case, that's also bigger than the 12-year balance for the house. So education wins on both times. Yay, education!